morning, guys. So what we're going to be working with today is we're going to be working with exclusively reflections. So the other day we started going over all the different types of transformations, right? And again, transformations are just ways of actually being able to move figures around. And through those we had four, right? We had rotations, we had translations, we had reflections, we had dilations. And out of those four, the only one that was different was dilations, because dilations is the only one that changes size. It got bigger, it got smaller. When it comes to all the other ones, translations, rotations, reflections, that represents isometry, right? Because all the shapes, all the figures stay congruent, they don't change size, they don't change anything, right? So when we started going over reflections, we saw that another word for reflections, was a flip, right? So if we're analyzing this, right, and let's say this, because what we're going to be working with today is we're actually going to be analyzing that there are different types of reflections, right? So we have this, and it's very important right here that we have that. That's X, that's Y, right? That's our X-axis, which always runs left and right. This is our Y-axis, which always runs up and down. So let's say that we have a triangle, right? And again, since we want to make this our first, right? Our first figure is always called our pre-image. The one that comes after is always called our image, right? So let's say we're looking at this, right? And again, whenever you reflect, you want to flip it. So I'm going to flip this, I'm going to reflect this triangle from here down here, right? So what's going to happen is, again, if I'm reflecting it over this, because that's the whole lesson, we're going to be learning that there are different types of reflections. If we were to flip it, if we were to reflect it down where my thumb is on A, if we're flipping it, if we're reflecting it, instead of being up there, it's going to come down, right? So now it's going to be upside down. And again, always keep in mind, regardless of how bad my drawings look, the triangles are supposed to be the same size. That looks too bad though. That looks horrible. And again, I'm sorry about how crooked everything is. Sorry I'm in the way as well right now. Here, hold on. Just trying to make it look good, guys. So we have that, right? And we have a triangle. And so again, there we go. So again, we had a reflection where we ended up flipping it. We ended up reflecting it from the top to the bottom, right? So if this was our original one, if this is our pre-image, A, if this is the one that comes last, we would make that A prime, right? Because again, A prime always comes last. The one without the prime is always first. That's our pre-image. This is our image. And now notice something. The reflection that we just did went from here to there, right? We literally reflected it over the X-axis, right? And that's the most important thing that we have to start analyzing, because this is what we're going to be seeing today. When you reflect it over the X-axis, that happens, right? So that right there was a reflection over the X-axis, right? Reflection over the X-axis. We literally reflected it over the X-axis. We took it from here, flipped it over the X, and it came down here. Now what we're going to be doing today, and it's important because we're going to go over all three of them, it's noticing what happens to the coordinates. So I'm just going to make up a coordinate. Let's say that this here would be 3, 5, right? And it's 3, 5 again. First one's always X. The second one is always Y. It went over 3, and then it went up 5, right? So there's a rule that always comes with certain types of reflections, right? In this case, when you reflect over the X, you're going to see the point, it went to the right, it's still to the right, right? So that's our X, that's our Y. It's still on the same side, right? So X didn't change, it's 3. But now, the 5 tells you that you went up 5, right? But since we're not going up anymore, now since the point is down here, instead of it being a positive, it's going to become a negative. And the reason that is, again, it's because the point, it's over here on the right side, right, on the X. The point's still here on the right side, but the only thing that changed is instead of being up here, it went down. And the one that affects up and down is your Y, goes up and down. That's why, again, we changed only the Y, right? If the Y was positive, it became negative. Let's say it was the opposite. If the Y was negative, it would become positive, right? And so there's a rule always for this. And the rule for this, and I'm going to write it this way just so you guys see it. Let me put it over here. which is going to end up being xy goes to x negative y. And all this means, guys, and again, we're going to be working with these a lot. All this means is whatever coordinate you have, all you do is just change the y. X always stays the same. And again, doesn't mean that y always has to be negative. It just means that it's always going to be the opposite y, the opposite sign. So if it's positive, it becomes negative. If it's negative, a negative and a negative becomes positive, right? So always remember, when you reflect over the x, you change the y. And the reason I'm going to show you this is a reflection over the x-axis, right? Now, I'm going to show you a reflection over the y-axis. Because when you reflect over the y-axis, it does start looking a little bit differently, right? So this now is going to be a reflection over the y-axis, right? So again, y-axis always goes up and down. Okay? X-axis always goes left to right. That's our x, that's our y, right? So now again, if we have a triangle, let's say, and I just want to keep putting it here just to show you guys. Let's say we have a triangle right there, right? And I'm going to make this point B, right? That's point B. If I'm going to reflect it over the y-axis, I'm going to flip it over the y-axis, we see that the y is right here, right? So what I want to do is, again, my thumb's on the vertex, on B. If I'm going to reflect it over the y, if I'm going to flip it over the y, I'm literally flipping it over y. But notice my thumb, where it's on B, right? Since it's on B right there, and I'm reflecting it over the y, flipping it over the y, it went from the right to now the left side, right? Again, the triangle still doesn't change shape, doesn't change size, but the only difference is instead of B being on the right, now it becomes on the left. B stays on the left now because again, we flipped it, right? And since this one now came last, if that's our pre-image B, this is going to be B prime. Because again, B prime always comes last, guys, always. Our image always comes last. And it's the same idea now. It's trying to analyze what's happening when we have that, right? Because now, again, I want to show you the same thing. Okay? Let's make up a coordinate for B. Let's say that B over here, let's say it's something like 7, 2, right? So the coordinate of B is 7, 2. And let's look at what happened, right? So we know that B used to be on the right side, but now B is on the left side, right? When we go left and right, that's our x. So we always know, first one's x, last one's always y, right? If we're literally changing it from the right to the left, right? If x is positive here, x now is going to be negative there, right? So instead of being positive 7, it's going to be negative 7, right? The good thing is, B was up here, right? B was positive up here. B is still up here. B is still positive up here. So if B didn't go down, B stays, if our second value didn't change, right? It's still up here, and this is still up here. Since they're still up here in these top quadrants, it means that y is still going to be positive, right? And the reason it's still positive is because, again, they're up here, so they stay positive. Because when you go up and down, that's why. It didn't change. It's still up top. The only difference is it went from the right, where x is positive, to the left, where x is negative. So our x became negative. And always remember that, guys. It's whenever you reflect over the y-axis, our x changes, right? So I'm going to represent that with a rule, and then I'm going to give you all these together again. When you reflect over the y, our x changes. So instead of being a positive x, it's going to be a negative x, and our y never changes, right? Y always stays the same. And again, that's our rule for when you reflect over the y-axis. And the one thing I'm going to teach you, there's always a small trick to remember. Whenever you reflect over the x, you change the y. When you reflect over the y, change the x. It's always the opposite, guys. Always change the opposite depending on what you're reflecting it over. And again, if it's negative, it becomes positive, okay? Don't ever think that it has to be this, it always has to be negative, because it doesn't. Our last reflection is a reflection over the line y equals x, right? It's a reflection over the line y equals x. And this is the one that people may get a little confused with. So literally, whenever you have the equation y equals x, it's a line that cuts right through there. And the reason it goes through there is because, again, if the equation is y equals x, whatever x is, y is, right? So if x is 1, y is 1, right? Because they're literally equal. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3, right? X is negative 1, y is negative 1, right? So it's literally that line. So when you reflect over the line y equals x, again, it seems complicated, but it's not. Let's say you had a triangle that looks like this, right? Where this here is going to be, let's call that one S, right? If I reflect it over y equals x, over this line, it's going to go from here to there, right? So it's going to end up looking like that because all we're doing, we're just reflecting it. And again, I'm sorry about the poor drawing, guys. It shouldn't get any bigger and all that. So if this was our original, if that was S, this is going to end up being S prime, right? It literally just reflected over that line, right? And now again, take into account, because this is what becomes interesting. Let's say that S is 1, 6, right? So we went to the right one, and then we went up 6. Now what happens here, if you notice it, is it went to the right a little bit, and then it went up a lot. Over here now, what happens is it's the opposite. Now we're going to the right a lot, and we're going up just a little bit. So what happens when you reflect over the y equals x line? They actually switch, they invert. So instead of being 1, 6, it now becomes 6, 1. No signs change, nothing like that. When you reflect over the line y equals x, the only thing you do is switch the order, because again, it switches the closeness of it. Basically, think of it here. This is really close to the y-axis. That's why it was 1. Now it's really close to the, sorry. It's really close to the, it's very high up, I'm sorry, that's what I meant to say. This one here is very high up on the y, so that's why y is very big, right? Over here, it's very high up on the x. That's why x is so big here. So think of it that way. Always remember, whenever you reflect over y equals x, you just flip the order, you don't change the signs. So looking at that rule, it would be xy goes to, and again, instead of being xy, all we do is just change the order, y, x. You just flip them around, guys. And again, it's just getting used to seeing all those rules, because once you get used to seeing them and knowing that, it's going to make using them so much easier. Because literally, once it comes to using them, it becomes the easiest thing. But again, let me write them down for you guys just to have them as a reference. So when you reflect over the x-axis, when you reflect over the x-axis, when you reflect over y-axis, and then when you reflect over y equals x, right? It's the 3 rules that we have. Reflect over y equals x. And again, remember the rules, because they are very easy, guys, to apply. It's just remembering them. Whenever you reflect over the x, always change the y, right? Whenever you reflect over the x, you always change the y. If the y is positive, it becomes negative. If the y is negative, it becomes positive. When you reflect over the y, you always change the x automatically, right? Always the opposite. If you reflect over the x, change the y. If you reflect over the y, change the x. When you reflect over y equals x, all you have to do is just change the order, guys. You don't change any signs whatsoever. You never change any of the signs. And that's it. It's literally that easy to remember, guys. It's just always changing one sign or the order of it. And now having this, it's being able to use them, which I'm going to show you just with 2 examples to show you how simple it actually is, right? So I'm going to give you guys a coordinate, and I'm going to ask you then to find the image of that coordinate, right? So what I'm going to do is I'm going to give you a coordinate. I'm going to tell you that we have the pre-image, right? We have the pre-image. And I'm going to give you the coordinate. Let's call it A, and let's call it 4, 5, right? You have the coordinate 4, 5. I'm going to want you to determine it after you reflect over the x-axis, right? What's it going to be after you reflect over the x-axis? What's it going to be after you reflect over the y-axis, right? And what's it going to be after you reflect it over the line y equals x, right? So I'm going to want to find this all based on that one coordinate, right? Y equals x. So again, we know that our coordinate, our pre-image, is 4, 5, right? We know that A is 4, 5, and we want to find the image of all of them, right? So if we reflect this over the x-axis, and if it helps, label it. That's our x, that's our y, right? Whenever we reflect over the x, you change the y, right? So we're only going to change the y. So if that 5 is positive here, it's going to become a negative 5, right? And again, the x stays the same. So whenever you reflect over the x, you just change the y, right? Now again, we're going to keep working with this original. Over here, when you reflect over the y, you just change the x. So instead of being a positive 4, it's going to become negative 4. And then again, y stays the same, right? Again, guys, we're not working with each of them. This has nothing to do with that. We just keep referring to the original one, right? So again, whenever you reflect over the x, you change the y. Whenever you reflect over the y, you just change the x. When you reflect over y equals x, you just change the order. So instead of being 4, 5, it's going to become 5, 4. And always remember, if these are our images, if that's A, that's going to be A prime, that's A prime, that's A prime, right? 3 different problems. So that's all it is, guys. Let me do one more just to show you guys, to make sure you guys have a good hang of it and that you guys understand it well, right? And again, once you get the hang of it, guys, it does become something extremely easy to work with. It's just getting used to it like anything else, you know what I mean? So again, I'm going to give you another coordinate. Let's say that I'm going to give you a coordinate I'm going to give you the coordinate of f, and I'm going to say that f is -2, -1, right? Okay, just getting used to seeing the negatives, guys. And if it helps, label them, right? That's our x, that's our y. So when we reflect over the x, again, you change your y, right? You just change the y. When we reflect over the x, again, change your y. If the y is a -1, it's going to become positive, right? And then x stays the same. And it makes sense, right? When you reflect over the x, you just change the y. X stays the same. When you reflect over the y, you just change the x, right? So if you're going to change the x, that -2 now is going to become +2, and then the y stays the same. And then always look back at it to make sure if it makes sense. When you reflect it over the x, you just change the y, right? Positive, negative, the other one's the same. When you reflect over the y, you change the x. -2 became +2, that stays the same. When you reflect over y equals x, again, you don't change any signs, guys, you just switch the order. So instead of being -2, -1, it's going to become -1, -2. And since these are all our images, if that's f, that's f prime, that's f prime, that's f prime. Again, guys, hopefully this helped. Let me know if you have any questions, okay? Take care.